I made up this problem. I don't know how it's going to go. Usually when you make up problems without working them out, then the numbers aren't all that terribly friendly. But I thought it would be a good one, and I'm going to talk my way through it with you, showing you how the units all work in it. So here it is, and you may want to copy this down because I'm going to have to erase the board and make some room. Alright, so one car takes off at 9 a.m. traveling 52 miles per hour. A second car takes off at 10 a.m. traveling 10 miles per hour faster in the same direction. The faster car arrives in Atlanta 20 minutes ahead of the slower car. So how far was the trip? Right, they're both going to Atlanta. And so how far was the trip? Okay, well, let's try to put this information together. And typical of all these rate, time, and distance problems is that you have two trips to consider. In this case, we have a slower car and a faster car. So let's write down what we know about each car. Alright, so the slower car, I'll just put slow. Slow car drives 52 miles per hour for how long? Well, we don't know when they arrived. And so let's just say that he drives 52 miles per hour for t number of hours. For t hours. Okay. And the faster car, I'll just put fast, he drives, well, let's see, he's going 10 miles an hour faster, so he's going how fast? He's going 62 miles per hour. And how long does he drive? Well, this is a little tricky because we're mixing minutes with hours. The faster car took off at 10 a.m., so he drove 1 hour less than the slower car. But also, the faster car arrives in Atlanta 20 minutes ahead of the slower car. So what's the difference there? 20 minutes is 1/3 of an hour. So he beat the slow car by 1/3 an hour. That means he drove 1/3 an hour less at that point. But he also drove 1 hour less because he took off at 10 o'clock rather than 9 o'clock. So the speed difference made a big difference in the long run. So if I counted correctly, 1 hour less here, 1/3 hour less there, that's 1 1/3 hours less, or 4/3 fewer hours than what the slow car drove. So he drove for t minus 4/3, so that's 1 1/3, changed to 4/3 hours. Alright, so make sure you understand what I've pulled all this information out. I think by far this was the tricky one, because again, fast car arrived 20 minutes before the other car, so that was 1/3 hour less, and then he took off 1 hour later, so that's also 1 hour less, so that was 1 1/3 hours less than what the slow car drove. Notice I'm using t for time. That's my habit. You can use x if you want to, but I like to use t for time. And since t represents the time the slow car drove, then the fast car is t minus 4/3. Alright, now I need to erase up here and then put this information together. So here I made some room on the board, and all this information down here came from the written part of the problem. So I took all that stuff I had written up and converted it into units. This guy drives at a speed for those many hours, and we also have to think about how far he went. Same here. So we figured out his speed, which was given to us, 10 miles an hour faster, And we also figured out how long he drove. All right, so see if we can put this together. And what do we know? We have speed and time, and what happens when you multiply those together? When I multiply these together, the hour units are going to cancel, leaving distance in miles. So the slow car drove, and how far did he drive? He drove 52 miles per hour for t hours. And what happens? The hour unit cancels, leaving miles. So this ends up being 52t miles. Okay, so we have his distance. It's 52t miles. How about the fast car? Fast car drove, I have a feeling I need a little more room here for the fast car. He's going 62 miles per hour times t minus 4/3 hours. And here, hours again cancel, leaving the miles units. So I end up with 62 parentheses t minus 4/3 miles. There we go. All right, now I know many, if not most students, really want to resist this units business that I'm harping on. But look, folks, if you want to get good, you got to learn them. All right, that's the bottom line. If you want to solve word problems and get better grades, and particularly if you have more algebra in your life to take, you'll still be using units. They still keep cropping up. So why not learn about them now? And but look what I've done. I'm not going to make that mistake of adding mismatched units together. I'm not going to take miles per hour and add hours and get miles, for example. I'm not going to do that because I've paid attention to the units. So what we know right now is we know how far each car drove. Slow car drove those many miles, fast car drove those many miles. Now, I'm missing one piece of the puzzle, aren't I? How do I relate these? Well, they drove the same distance. So there's usually one little piece of these rate, time, and distance problems where you have to figure out how to relate the two different trips. And in this case, they drove the same distance, which means what? That means I can set these equal to each other. And when I do, I'll have miles equal to miles, which is what we're supposed to have. So at that point, I'm going to ignore the units because the units all match up in the equation. So now I'm going to concentrate on solving for t. So make a little more room here.